Now we'll have a quick summary of amplifier topologies we have discussed so far. The very first thing we discussed was the common source amplifier, and here I have shown the common source amplifier with source feedback technique for biasing. Of course we can use other techniques as well. And after this we discussed the control sources. So we have the common drain amplifier or the voltage control voltage source here, and source degeneration or the voltage control current source over there. I have shown the load as something in series with the drain. You can also use an inductor and AC couple the load. We also have the common gate amplifier, which is a current controlled current source, and a drain feedback amplifier, which is a current controlled voltage source. Okay. Now often it's common to see these three, the common source amplifier and common drain amplifier and common gate amplifier, presented as basic stages. In our case we have classified them somewhat differently. This is the basic amplifier without feedback, and all these four amplifiers incorporate feedback. Okay. Now I have repeatedly emphasized that it's important to understand the logic behind the circuit rather than trying to just memorize the circuit. You can see why. Because these circuits, these all use the same biasing technique, source feedback, and they all kind of look the same also. Okay. So if you didn't understand the function of every component, you won't be able to distinguish between, let's say, this one and that one, and something that has a resistive load and something else and so on. Okay. So these are the basic single transistor amplifiers, and their small signal pictures are given here, and you can analyze the transfer function or any other quantity, input resistance, output resistance and so on, using this picture. In many of our analysis we omitted GDS. It doesn't have any profound effect, but in some cases it does. You can still analyze them using linear circuit analysis. Now I said that this amplifier doesn't have feedback, whereas all these do. How do you tell if there is feedback around a transistor or not? There is a systematic way of doing that. Now what is the meaning of there is feedback around a transistor? The transistor has a controlling side, which is the gate source voltage, and the controlled part, which is the drain current. Now if any portion of the drain current is fed back as VGS, then we say that there is feedback, and if the feedback is in a particular sense, then it is negative feedback. Okay. So how do we evaluate if there is negative feedback? What we do is the following. We set the independent input to the circuit to 0. Okay, we set Vi to 0. That is not relevant here. And then the transistor's control source is replaced by a fixed current source. Okay, and that is shown here. We have set the input to 0, Vi is 0 here, so it's replaced by a short circuit, and II, the current input, is 0, so it's replaced by an open circuit. I've also replaced the control source inside the transistor with an independent current source, okay, ID, which is shown in red in each of these cases. So what you do is the following. In these circuits you find VGS. If VGS is not 0, remember in these circuits the only source is this current ID, and if a circuit happens to have more than one independent source, you set all of them to 0. The only independent source remaining should be the one which is substituted in place of the control source within the transistor. If this gate source voltage happens to be non-zero, that means that there is feedback. Okay, somehow a part of this ID is going through the circuit and is appearing as VGS. Okay. Now because these are all linear circuits, VGS will be of the form of something times ID. Okay. If this is not 0, there is feedback. Let me just say alpha. Alpha is not 0, implies there is feedback around the transistor. And if alpha is less than 0, this means that there is negative feedback. Okay. These circuits are all quite easy to analyze. You can do it one by one and see that VGS turns out to be some negative number times ID in these four cases, whereas it will be 0 in this case. Okay. So this is how you tell if there is negative feedback, and if there is negative feedback and it's very strong, that is if GM is very high, then you can use the concept of virtual short to simplify your analysis. This was discussed in one of the earlier lessons. Okay.